Hello, STEAM friends. Do I look funny to you today? You look funny to me too. Have you figured out why yet? These bend or refract the light. You try. Can you see me? So silly! Today, we are going to talk about light and shadow. We've already talked about translucent, transparent, and opaque, and the sun. But keep those in mind because they're going to come up too. But our new big words today are reflection, which is like when you look in the mirror and the light bounces off. Refraction, which is how light bends. And I'm going to show you what a solar eclipse looks like. And what a lunar eclipse looks like. Remember we talked about when you're reading words? So this is the word eclipse. And it's the same. Solar eclipse, lunar eclipse. A solar eclipse just means the sun. And a lunar eclipse just means the moon. And we are going to talk about the spectrum of light. This time, our animal is the giant panda. Look at that giant panda. Isn't he so cute? You might have seen a giant panda at our zoo, but they are native to China, which means that's where they normally live. And I don't know if you look very closely, if you can see that he is shaking water off his fur. You see those water droplets? I chose the panda with the water droplets because we are going to talk about how water droplets refract light and make rainbows. I know, we all love rainbows. Rainbows are just the spectrum of light. A rainbow is how we can see the whole spectrum of light. Every color in the rainbow is in white light. And we've talked about our skeletal system when we talked about the bones in our foot. This is your entire skeletal system. Those are all the bones in your body. And today, the part of the skeletal system that we are going to talk about is your skull. That is what the bones in your head look like. Inside, see? There's the nose. Don't pick the nose. There are the teeth. There's the mouth. That's the eye socket where your eyeball is. Remember, we talked about eyeballs. Okay. So, we are going to head over to the whiteboard to talk about light, shadow, reflection, refraction, solar eclipse, lunar eclipse, the spectrum of light. And then we're going to play with reflection, refraction, and shadow. Sound fun? Let's get started. Can you see my shadow? Can you see my hand? Can you see how it changes as it gets closer and further away? Closer and further away. You can do a shadow dance with your shadow and watch your shadow move when you do. You can even take a piece of paper, put it on the wall, and try to trace your shadow. This week, have some fun playing with your shadow. I am going to teach you a magic trick that you can do at home using refraction. Look, see this card that I put an arrow on? Which direction does the arrow face? Watch when I put it behind the glass of water. Can you see it bend? Can you see it facing the other way? Oh my goodness! Same card. Nice straight arrow pointing this way. But when I put it over here, I can make it flip sides and bend and wave and all kinds of fun stuff. Check this out. I have all these fun little papers. And somewhere in here, oh, little turtles. You see the little turtles? They're facing this way. But look at the turtles behind the glass of water. Which way are their heads facing? The other way. Now, if you don't have pretty paper with little turtles or little buses at home, you can just draw any picture you want. And you can make it move in your glass of water. Watch. I'm gonna make this guy dance. Oh, he's got two heads. Pretty cool, right? Just a little stick figure. But it can be all kinds of art when the water in the glass refracts it. Refraction just means that light rays bend. So as they're coming in from the air and they pass through the water and they bounce back to your eyeball, they bend in all kinds of cool ways going through water. Okay, friends, first we're going to talk about light. You all know what light is. It's how we see. Do you see my flashlight here? Do you see the rays of light coming out from it? Keep that in mind. We're going to need to remember that when we talk about shadow. But when light travels from one transparent medium, the air, can you see through the air? That's how you know it's transparent. When it travels through one transparent medium and into another, water is transparent. Can you see through it? I can see through it. It's transparent. It slows down and it changes direction. Remember we talked about fast wavelengths and slow wavelengths. When it travels in, it's going at its normal speed. But when it passes through this glass of water, it slows down and it changes direction. Now, the exact same thing happens when it travels through raindrops, because rain is made of what? Water. Huh? Look at that. But something very special can happen when it travels through raindrops or water particles in the air. A very special kind of refraction happens called a rainbow. The rainbow is all the colors in our spectrum of light, our visible spectrum of light that we can see. All these colors, red and orange, yellow, green, and blue. Last there's indigo and a pretty violet too. Red and orange, yellow, green, and blue. Last there's indigo and a pretty violet too. Remember we talked about how all of these colors of light have different wavelengths, different frequencies. So when it is refracted through the water droplets, it makes a rainbow. And the rainbow is our visible spectrum of light. All the colors of light that your eyes can see. Pretty cool, right? They all have different frequencies. bouncies. So when they're refracted, white light, plain old sunlight, can make rainbows. Oh, so cool. We love rainbows. All right, my friends. Now, let's talk about shadows. Shadows are just the absence of light. It's where the light gets blocked. So, assuming my little object right here is opaque. Opaque means the light doesn't go through it, right? So it's going to cast a shadow. It's going to cast a shadow that's very dark right up behind it because no light can get around there. And then it's going to get lighter the further away you get. And even though the shadow will change shape depending on how you move your object, it's always going to be, you're always going to be able to tell that it's kind of the shape of your object. Like the shadow of my hand is going to look very different than the shadow of this rectangle, right? You guys have seen your shadow in sunlight before. It's not a rectangle, it's the shape of you. It might be a weird stretched out shape of you, but it looks like you. Okay, now something else would happen if this little object right here is shiny like a mirror. It's going to reflect light. We talked earlier about how when you're reading words, you want to see what parts are the same, right? So both reflection and refraction start with R-E. Reflection is the light that bounces off, and refraction is how light is bent. So a reflection, just like your reflection in a mirror, is the light that bounces back to your eyes. So when you look in the mirror, the light of the image of you is reflected into your eyes. Pretty cool, right? So reflection is just the light that bounces off the object. Reflection is the light that bounces off. Refraction is how the light is bent. Let's explore that further on a piece of paper with a flashlight. If you have a flashlight at your house, you can play too. Otherwise, you can watch and just play along later. Oh, I almost forgot. I can't forget the most cool shadows in our entire solar system. I want to talk about a lunar eclipse and a solar eclipse. Remember, look for the parts that are the same. Eclipse is the same word. Lunar means moon. Solar means sun. See? S like sun. Solar eclipse. Lunar eclipse. A lunar eclipse, remember when we talked about how the earth revolves around the sun and the moon revolves around the earth? Okay, so there's very special times where, because of where they are in their orbit, remember, the orbit is just the path they take to revolve around the sun or around the earth. They line up just right so that in a lunar eclipse, the moon falls in the earth's shadow. So the sunlight comes down, but the earth blocks it. And we can't see the moon. Because the moon, unlike the sun, doesn't make its own light. It reflects the sun's light back to us. So if it's in a shadow, it can't reflect light back to us, can it? There's no light. It's blocked. It's in a shadow. That is a lunar eclipse when the moon is in the Earth's shadow. A solar eclipse is when the Earth is in the moon's shadow. So the sunlight comes down and it hits the moon, but the earth goes dark because it is in the shadow. And even in what should be broad daylight, the middle of the day, it can be dark because we're standing in the shadow of the moon. Pretty cool, right? Okay, now we'll explore that a little more on paper. Who turned out the lights? Okay, the reason that I have the lights turned off and only this flashlight, which I, if you can see, put tape over so that you can only see a little slit of light come out. I'm not sure how well you can see that on the camera, but you don't have to do that. I just did it so it would be really clear when I make this little shiny object cast a reflection. Can you see where it casts a reflection on the paper? I can see it really clearly on my paper, and when I move the object, the reflection moves. Can you see how when I move the object, the reflection moves? Okay, that is reflection. Whichever way I turn the object, it reflects light in that direction. Looks like, even though I thought it would be better on black paper, it's actually even more obvious on white paper. Look at that. The reflection off the object moves as I move the object. See the reflection move? You can find all kinds of things in your house that can reflect the light from your flashlight. Okay. Now, let's talk about shadows. Now, my friends know that my favorite paper is graph paper, and you cannot even see the little squares on this paper, but it has all these little squares on it. And the reason I love graph paper is because it's like math and art in one. So you can see the light coming out of my flashlight, and you can see how the light changes depending on where I move the flashlight. Now, let's try to make a shadow. Can you see how the object blocks the light? Can you see how the shape of the shadow changes depending on where I move the light? Let's see if I can get a really nice shadow, because I wanted to work with you guys on tracing a shadow. And this little rectangle is going to be great for that, because the lines off of it are going to be nice and straight. So let's see, maybe if I prop it up on my phone. That helps me get it straight on. All right, now I'm going to trace the shadow. See how the light goes around the object, but it can't go through it because the object is opaque. I would like you to take a flashlight or go out in the sunshine, cast a shadow, and try to trace a shadow. You can do your shadow, you can do the shadow of an object. See how I moved the object and the shadow moves? See if you can make the shadow bigger or smaller. See if you can change the direction of the shadow. See how now it's coming out like this. Look at that. It stays basically the shape of the object. So if I do my hand has a very different shape shadow. See my finger? My finger's not a rectangle, is it? No, it has a very different shadow. And depending on where I move the light, the shadow gets different. So this week's homework is for you to do your own shadow drawing. Now here's something special just for my pre-K friends. When I went to talk to the kindergarten teachers at Blessed Sacrament, I asked them what kind of things should I be doing with my students to help prepare them for kindergarten. And one of the things they recommended to me was pinpoint art. Now, ask your mom or dad before you do this because you need something sharp. I have a push pin. And I'm going to draw a little picture. I'm going to go along it and just make little holes. You want to put something soft underneath it, like a piece of cardboard. I used a few washcloths folded together. And just trace your outline with little holes. You can do this with a piece of paper. You can print a picture with your computer, but I chose tinfoil because it is both reflective and opaque. Pretty cool. So I thought that would tie in with our lesson really well. Can you see the picture? What did I make? Can you see the star? Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are. And if you think about all those little dots like they were stars, I made a constellation. A constellation is just a group of stars that make a picture. Pretty cool, right? Okay, friends, we're back at my pretend bulletin board so we can wrap this up. Today, we talked about light, and shadow. Shadow is just when the light gets blocked and it's dark. Okay. We met our giant panda. Giant panda. The giant panda is native, which means he lives in China, and he likes to eat bamboo. Do you like to eat bamboo? I don't think we can eat bamboo. Too crunchy. And he's black and white, and he has these fuzzy black eye patches, like glasses. And I chose this giant panda because of the water droplets all around him. Have you ever seen a puppy dog shake the water off its fur? Have you ever given a puppy dog a bath and seen him shake, 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 and the water goes flying everywhere? Do you see all those water droplets flying everywhere around my giant panda? I bet if there was sunlight going through those water droplets, we would see a rainbow. And a rainbow is just the spectrum of light that we can see. See? Light. And it's caused by refraction. Refraction is just how light bends when it goes from one transparent medium to another. The air is transparent and water is transparent. So when it goes from air into water, it slows down and it bends, and that is called refraction. And that's what makes rainbows. Now, when light hits something that's opaque, it's blocked and creates a shadow. We talked about some really cool shadows in our environment, in the world, in the universe. We talked about a solar eclipse. Solar eclipse. And a solar eclipse is when the moon is in between the sun and the earth. When they're on their orbit as they revolve, right? And when the moon is blocking the earth and we are in the shadow, it gets dark in the daytime because we can't see the sun. It's blocked by the moon. And we talked about how the sun makes light, right? We knew that. Sunlight. But the moon doesn't make its own light. It just reflects the sun's light. Reflection, like a mirror. And so during a lunar eclipse, the moon is in the Earth's shadow. So the sunlight is coming down, but the Earth blocks it. And so, in a lunar eclipse, that moon can't reflect the sun's light. S-U-N, you know that one. Oh, Mr. Sun, Sun, Mr. Golden Sun, please shine down on me. But the moon can't shine. Stars can shine because the sun is a star. But the moon can just reflect the sun's light. Okay? Now, if you are one of my pre-K friends, we worked our fine motor skills today by doing punch art with something sharp. Okay? And we made a group of dots that kind of look like a group of stars, which is called a constellation. Did that last time, right? Talked about constellations, but this time we made one and we used our fine motor skills. Remember, I told you guys you should be practicing your fine motor skills at home right now, because anything you do that uses your hands, like stringing beads or drawing or cutting, those are using your fine motor skills, and those are very important for kindergarten. So I hope my pre-K friends will do that project. And I hope my other friends and my pre-K friends too, just because it's going to be fun, will play with light and shadows and maybe try to trace a shadow or try to trace a reflection. See what you can do. Okay? And then last but not least, we revisited our skeletal system. Remember last time we looked at the bones in the foot. There are the bones in the foot. This is your whole skeletal system. And up there at the tippy top is your skull. Those are the bones inside your head. This is what it looks like inside your head. Do you see the mouth? And the eye socket? And the nose? And this is where your brain is. Inside your skull. Knock it. It's hard. That is your skull. Okay, my friends. Now, I don't have a song about the refraction of light, but my favorite rainbow song that I was hoping we could go out on today is The World is a Rainbow by Greg and Steve. Now, normally I would just play that for you guys on my handy dandy Bluetooth speaker, but YouTube has rules. No, get in big trouble for using somebody else's song like that. So I am going to sing it for you because I figure that's safe. People do covers all the time, right? Okay, so if you know the words, you can sing it with me. Ready? The world is a rainbow that's filled with many colors. Yellow, black, and white, and brown. You see them all around. The world is a rainbow with many kinds of people. It takes all kinds of people to make the world go round. So you be you and I'll be me. That's the way we were meant to be. The world is a mixing cup. Just look what happens when you stir it up. The world is a rainbow with many kinds of people. And when we work together, it's such a sight to see. The world is beautiful when we live in harmony. All right, you guys, I love you very much and I miss you, and I hope you had fun doing this with me today, and I will see you next time. Bye.